Recording in progress.
And then I'm going to turn off the waiting room.
Yeah, just so there's no one blocked.
Yep. So that should let anybody come in now.
So people can people hear me in addition to you two?
I can hear you loud and clear.
Okay, excellent. Well, hey, welcome everyone. The delay is on my part. I started 15 minutes early and ended 4 minutes late. So story of my IT life, I guess. So I apologize. That's on me. Welcome to Tech Tuesday. I appreciate everybody joining. I see we've got 18 online and it is recorded. And we've seen great success with these recordings being sent out. And even before we get to, I want to put in a plug for this. The reason we want to record these is to allow you guys as producers to send them out to municipalities, to obviously contractors where a pre-construct could come into play. So we're really trying to expand the audience. So with that, Dana, should we go through a couple of these first slides? Yeah, antitrust, we start with that. As you know, we'll follow the antitrust guidelines, which means in principle that we won't discuss individual customers or pricing of any sort. So thank you for that. So this is just a plug for these. We welcome people that are not members to the Tech Tuesdays, and especially if you're sending it out to people, but at the same time, we're putting in a plug, trying to grow our membership and help the industry as much as we can. So people want to find out more information about membership, go to CRMCA.org. Thank you. So we're going to start with the Tech Tuesday, and we've got, I'll let Dana introduce himself. Many of you already know Dana, but I think we have a slide on sponsorship. And so I want to, as we talk about pre-construction plans and meetings and so forth, we've got our sponsors all listed here. And rather than me spend more time since I'm running further behind on that, thank you very much to our sponsors, and please reach out to them yourself and support our sponsors.
Right.
Well, let me, and Dana, please introduce yourself. But many of you guys know Dana, and while he switched his role, we wouldn't let him get away that easily. He's done many Tech Tuesdays, many training sessions for us, and so Dana, I really appreciate you taking the time to do this, and I'll let you introduce yourself and the presentation.
Great. Well, appreciate y'all being here. My name is Dana Rakovich. I'm with KB Concrete Systems. Been in the ready mix industry now for almost 20 years as a whole. So I've been doing this for a long time, a lot of years on the ready mix side, and then now on the construction side of things. So this kind of is fitting because it's kind of a role swap and talking a little bit about these pre-construction plans and why they're so important. So we'll get into that. So the pre-construction meeting, you know, are really important. It's critical to the success of projects that you have a quality pre-construction meeting. And so this is a kind of a list of all the people who we generally would say should come to a pre-construction meeting. This is really who generally shows up to a pre-construction meeting. Most of the time, the general contractor, the concrete contractor, and the engineer get together. And that's okay, but really it would be far better if at least the ready mix supplier, the testing lab, and the pump company were to have shown up to that meeting to make sure that they're a part of that. We'll talk more about why that's so critical and why each of those people, but they're all stakeholders, right? They all have information and things that they need to get on the table for good dialogue and for good understanding of all the pieces and parts, right? And then idealistically, we'd love it if the architect and the owner were to show up as well. I think that's a bit of a pipe dream. You're going to very seldom see the owner and the architect choose to show up to a pre-construction meeting. but at least the blue and green section of people really should be in the room when you're having a pre-construction meeting. It's just critical to success. So at the end of the day, are pre-construction meetings really all that important, right? Well, yeah, I think they establish clear communication, right? It's it's easy to say we communicate, but not understand if whether those in the room or other people communicate. So if you don't sit down and have a dialogue, things get missed, right? You say things, you talk about things, and you just have assumed that other people are on the same page as you. When you sit at a room like this, you have a better job of getting your goals out, to making sure that we know what the objectives are, and so that everybody's in lockstep and in line with that, right? And then, of course, being proactive in your planning is helpful at a pre-construction. If you're not, you're going to end up being reactive and doing triage, right? I mean, that's the thing, right? At the end of the day, nobody wants to be in triage mode, but I can tell you over my years, far more often, that's what happens when you don't have these meetings, when everyone doesn't get to the table and talk about the things that are going on and what they have and what all is involved. And you end up in these triage moments where things are falling apart. It's not going the way it's supposed to go. And usually you have a bad pour or something bad going on. And then what do we end up doing? Everyone ends up getting into the room to discuss what went wrong and why it went wrong, right? When all of that could have been resolved had we done it early, right? We could have talked about what was going on, potential issues and all that stuff, right? So, and also shared experience is also a component of that, right? So clarity in the chain of command is also important, as a piece of this. Who has what roles, who has what responsibilities, is really important. Who rejects the truck, who makes decisions for adding water into a mix, right? Who decides whether something has to move, or understands what things could be in the way of efficiently getting a pour done. All those kinds of things are really important. And when you wait until the day of the pour and people don't know who's in charge, obviously we all know what that creates, right? And then obviously timelines, something as simple as that, right? Let's avoid the surprises, right? And the delays. Let's make sure that, we're as efficient in everything that we do. And we all know that, right? When you're efficient, we are far more profitable when everyone's efficient on the job site, right? And costs are always an issue for any job, right? So, and then obviously we foster collaboration and teamwork, right? That's really important. Anytime you get people to the table and you have time to talk to each other, the side effect of that is collaboration and teamwork, right? That is just so much better when people come and sit around the table with each other. So what are some agenda items? So I kind of broke these up into like categories, right, of stuff that needs to be discussed, right? So like agenda items that could be at a pre-construction meeting is obviously just basic project information, right, and schedule. That may not seem like a big deal, but really understanding a schedule from a ready-mix supplier standpoint or the concrete contractor standpoint is really important, right? The more you understand about where that schedule falls, and you'd think that that's naturally communicated, but it isn't. I can tell you on the ready-mix side, it's far more often that you don't know the schedule than it is that you do know the schedule, right? Of when things get poured and what's going on. So having that information is important for how you plan and what other projects you take on. Obviously, what kind of materials are you using, right? And what are the mixes, right? What's the pour schedule look like? And what does sequencing look like, right? Understanding that helps you to understand that when you have weather days, you can understand better how the schedule overall is impacted, right? If you sit down and have a discussion around pour scheduling and sequencing. Obviously, site access, really an important discussion. Where do you come in? Where do you leave? Are there rules around that? Do we have limitations due to noise ordinances and things of that nature? All of that needs to come out and be discussed, right? How does that affect things? Where's the concrete washout going to be? Is it sized properly, right? Does the location make sense? I've been on projects where, we've put the concrete washout in a location where you can really have a one-way street access in and out of this thing. So now you have one of the busiest places on a concrete pour is the washout, because every truck's got to come in and out of there. And now you have a one-way road getting in and out of that location, right? Which can really create bottlenecking and affect the pour, in a whole different way. So, and then obviously what's the base and the subgrade preparation, and, who gives acceptance to that, and, how does that work? For making sure that it's done in enough time so that we don't have poor cancellations and things of that nature, right? I think the propensity is to want to do a proof roll, the night before, but is that really the best time in case something goes wrong, right? But I do understand that rain events and things of that happen, you got to come back and double check them. So there's always counterbalance in that, but the more you can sit down and have these kind of talks, so that everyone knows what's up for grabs, and if cancellations could come, when would they come, right? From that perspective. So, and then we kind of start talking about, now we're into, all right, we've got everything ready. Now we're going to pour, right? What's the delivery method? Are you pumping it? Are you tailgating it? This is important too, because there's a lot of things that are affected by which method of delivery you choose to go after, right? If you are tailgating something, understand that, a ready mix truck has 70,000 pounds on a short axle, right? Going down into your subgrade. So even though your subgrade may proof roll well, you put 10, 15, 20, 50 trucks, depending on the size of the pour that you have, going down a certain road at 70,000 pounds, it's going to start to affect that subgrade, right? And can we have that discussion, right? Do we dialogue about what happens to your subgrade, with trucks going on top of it? Do we need a roller to keep compacting it over time? Do we need to prep drivers to understand that they can't turn on the subgrade? Because obviously the more you turn on a subgrade, the more potential you have of tearing it up. So do we need more alleyways or more open face so that trucks are driving in a straight line, down the columns of the pour, or something of that nature, if we are tailgating something? And then, again, if you're tailgating walls and things of that nature, there's a dialogue around that, right? What's the slope? How far can that truck come, right? You need a 1-to-1. So for every 1 foot down, the truck has to be 1 foot away from the edge of that excavation. So if you've got a 4-foot wall and you got to be 4 foot away, how many chutes do you get on? Can you effectively shoot the thing that you're planning on using a truck to tailgate? And then it's also understanding that even in tailgating, there's extended wash times when you tailgate something, right? And so what does that do for everybody? And then is the washout, again, you got to go back to this washout sizing, right? Is it sized right? Because now if every driver's got to wash 3 chutes down, now instead of having 4 trucks at the washout, maybe now you've got 6 trucks or 8 trucks at the washout at one time, right? And now is it appropriately sized for that? And then we talk about concrete ordering and, how many cubic yards, per hour you got it, and what is the ordering process for that supplier? Is there, do they have certain rules? How do they handle will calls? When are cancellations allowed? What are the short loads, right? Well, all those different things around ordering that are important. And then really, what's the desired cubic yards per hour obviously is critically important, right? And then can you hit that cubic yard per hour based on, with your traffic pattern, as we'll talk about here in a second, versus, how many lanes do you have for tailgating, and can you get enough trucks in and out in an efficient amount of time, right? And then is the mix pumpable enough for the cubic yards you want? Some mixes, depending on what they are, may not pump at 120, 130 cubic yards an hour, right? They may only pump at 50 or 60 cubic yards an hour because of their makeup and how they're designed. So is the mix even going to fit for what you want? And then obviously one that's really important is truck flow, right? Do you have a pathway that's conducive to the yards per hour, right? Can you get 2 trucks to the pump at all times, right? In a fair and even way? Is road access allow that to happen? I've seen a lot of times where you end up in a situation where you see that truck pull in, right? And then he's got to do this 5-6 point turn in order to turn to get to the pump, right? That's an ineffective way to hit a high cubic yard per hour, right? So now you're asking trucks to do something that won't yield you what you're looking for, right? So these kinds of discussion become really important, right, early on, to make sure that everyone's there. And this is why it's important to have the producer there and the pump company there to have these kinds of interactions together, right? and not just the contractor who says, yeah, we're going to go this fast. And they're thinking about it from a placement standpoint, right? Hey, can we put it down at this kind of quantity at this kind of speed? Whereas, the pump company is looking at it from a different perspective, and the ready mix supplier is as well, right? And then how are we doing with concrete testing? Well, what is the frequency of testing, right? What are the procedures that need to be followed? And do we talk about that? And so again, the testing lab is critically important to be present in here, as well as a general contractor, because of kind of how these relationships marry together. And so it becomes really important as we do this, that, we have a good discussion around, what's the expectations of that, right? And then what is acceptable quality concrete, right? What's the slump requirements, the air requirements of each of the mixes? Is everyone in agreement on that? How's the engineer stamped it? Are we clarified on all of those kinds of things, right? And then what are the rules around job site adjustments, right? Can the concrete be adjusted? If so, when? How many times can it be adjusted, right? And just making sure that we're clear on the rules of this thing. We'll talk about this as we go into the pre-construction checklist from CRMCA into some more details around this stuff, but this is just some of the things that become really important, right? And then test cylinders and storage and care. Where are you putting those test cylinders? This is a critical part to every job, and we'll spend a fair amount of time talking around this subject because it's such an important piece of a good pre-construction checklist when it comes to concrete, right? And then, we go into the actual placement now, right? So now, what's the rules around, placement and consolidation? And, do you have pocket areas where, you see this a lot? You get into post-tension type slabs and things of that nature. And, I've been on jobs where nobody had a discussion and nobody brought a pencil vibrator, right? And now you're going into these really tight areas, around all the tendons on a post-tension job, or, we've got a ton of rebar in a column and nobody brought a pencil vibrator. They brought a normal vibrator, but not one that's small enough to really get into those areas to make sure that real consolidation is happening, right? And so having these kinds of dialogues are really important up front. What are the finishing requirements here? How are we going to finish it? What's the expectations? How are we getting our power trowels up on the slab if there is one, right? Or what's the expected, FF and FLs for the floor as we place it, and then really becomes important on things like jointing and saw cutting and timing of these kinds of processes. And I would tell you even more so now as we move into, colder months, versus the hot months of the summer, and these kind of temperature changes that we're having right now really become important when you start talking about jointing and cutting and understanding the rules around that, right? And how each one affects the other. People can choose in these cool kind of fall days that they don't accelerate, right? And that can be good in some regards, but you're coming out of the heat of the summer and now you're in that really kind of soft spot where maybe the concrete's laying there a little longer before you're able to saw cut it. And now you're exposing it to environmental changes for longer periods of time, right? And if you do that, you can't get on and saw cut it because it hasn't hardened enough to get up on top of it, but yet you're still seeing the effects of the environment around you, right? And so having dialogues around this, around jointing and cutting procedures and the timing of those procedures becomes really important dialogue to have ahead of time, right? And even just discussions of, shape and geometry of the pores and what do they look like, right? Is there some requirement on the job that's requiring you to pour big rectangles, right? Instead of concrete loves to shrink in squares, right? And that's the best way to pour concrete is in squares. From a jointing standpoint, it just allows shrinkage to happen in 365 degrees. But you get into these situations where you've got long rectangles, sometimes it's forced by the job and the situation and the way it's created. But when you have that, having a dialogue about jointing and understanding that you may need to jump certain joints, right? And do relief cuts and then come back and cut those intermediate joints back inside of it. But having these kinds of dialogues around that kind of stuff really becomes important. And then curing and protection of the slab, right? Not just getting on it and how critical it is to get a good cure on top of anything that you've got. But then what's the protection look like for the slab or the element, right? The wall. A lot of times in Colorado, we've been blessed in a lot of ways with some of our weather that, we'll pour columns or things of that nature, and we'll pour them at 3 and 4 o'clock in the afternoon. And then, we throw a blanket over them when it gets down to 35, 25 degrees overnight. Is that adequate protection? As we all know, concrete's changed a little bit over the last couple of years as we move into some greener concretes. And so part of that side effect is some heat change stuff that exists. And so winter protection may need to be addressed differently, right? And so having a pre-con meeting where you can have that dialogue becomes really important to sit down and talk about these kinds of things. And then, hot and cold weather, precautions and adjustments, right? Now, when it's hot or when it's cold, what do you have to do? And again, this becomes even more important in the shoulder seasons. Fall and spring is where I tend to see more issues where we should have had pre-construction discussions. Why? Because it's these moderate temperatures and everyone thinks everything's fine. But in Colorado, we have huge swings in these shoulder seasons, right? It's not unusual to get down to 30 degrees at night and get up to 60 or 70 degrees in the afternoon or the day, right? And so that kind of 30 and 40 degree swing is a huge thermal change that concrete goes through, right? And so there's a lot of things that happen when thermal change of that kind of swing happens when it comes to the way concrete shrinks, the way it cures, expansion and contraction, the dangers of freezing, all of those kinds of things. So it's really important to sit down with your producers and have these kinds of dialogues and your concrete contractors to make sure that you all understand what's happening. Tends to me to see less of an issue in the actual summer and winter because everyone's assuming it's winter or summer, right? You've already made those adjustments for that. It's the shoulder seasons that really become problematic, in my opinion, around this stuff. But, we have vapor barrier or retarders in place. And what does that do? Concrete cures differently when it's on vapor barrier than when it's not. And so if you have a pour where a certain office section has vapor barrier and the rest of the slab doesn't, do we understand that those setting times are going to be very different in the sections that are on top of vapor barrier? Concrete tends to get much hotter in those areas. And so it tends to set faster and quicker. But there's also a difference in the way it's going to bleed. Vapor barrier has no place for water to go down and to bleed into the ground or the subgrade below it. So all that bleed water only comes up, right, in those sections. So it's going to set differently from that perspective as opposed to the sections of the slab who may not have vapor barrier. And you get a moisture loss through those, into the ground. And then do we have specialty products that are going to affect our procedures? Are there shake-on hardeners that are going to go on top of here? Is there some sort of fiber that's being put inside, inside the product? And does that affect the pumping agency, right? Because of the way that fiber comes. Do they maybe need round bar grate as opposed to a slatted grate due to the specialty products that they've got? What any of a number of procedures can change, right? And do those things affect, are we running steel fibers? And does the procedures affect the contractor? Does it affect, the finish going on the slab? Does it affect the ready mix supplier, right? Those are all things that need to be discussed because there's a wide variety of specialty products and all those things are different from each other, right? And when we talk specialty products, we're not even just talking about the things that I've mentioned. We're also talking about, could you have a waterproofing, admixture put into that? And how does that affect it? Does the ready mix supplier need to be prepared for that because it may affect the drums in a different way and clean out of their drums and things of that nature? So just lots of things to be had discussions around, anytime you have specialty products. And then to me, something that almost never happens in a pre-construction meeting, but should, is do we talk about the what ifs, right? If there's poor disruption, the pump goes down, the plant, heaven forbid, has a breakdown, right? The laser screed breaks down, that we have lots of pieces and parts here that all have to work together. But what happens if one of those things fails, right? What do we do? Where do we go from here, right? What's our plan of action? Are we bulkheading, right? What happens if we've got, what happens if the laser screed goes down and it won't come up and, you were going at 120 an hour and you've got 15 trucks on the road coming to you and as we all know, if you're gonna hand screed that, suddenly you went from 120 an hour to 60 or 70 yards an hour that you can put down, right, in hand screed. So what are we gonna do about that? How does that affect the pour? What's our plan? Are we gonna keep going or are we gonna put a bulkhead in and just try to get through what we've got? I just don't see enough of this in discussion, and it really should, right? And this isn't just, flat pours, but this can be huge wall pours and things of that nature. Heck, if you have mass concrete pours, right? Really want to have some dialogues around things like that, around what are we doing and how do we handle, bad situation happening, and do we have a backup plan? And if so, what does that look like? And what's timelines to, interact with that backup plan to get them online, and what is realistic timelines for everybody? So just some of those things to look at, and then obviously, what does the surface finish requirements look like, and who dictates what we're accepting, right? From that perspective. So, and then, obviously, other critically important, things that we don't is what's job site safety look like? Do we have concerns around that? Are there specific requirements that we really should have a dialogue around? And then who gets the test results post the pour? This is a hugely an issue often, is that you don't have good distribution of the test results. So the testing company, works for the owner maybe, and they're sending the test reports to the owner and the general contractor, but the concrete contractor and or the ready mix supplier don't get the test results, right? And then we start to have, failing tests or something that's going wrong and nobody knows anything about it until, we're probably way down this path because we just don't have good distribution habits as to who gets the test results. And that, specification and ACI and ASTM both dictate that all the responsible stakeholders have to get these test reports, right? That they're required to get them, but that seldom actually happens. So do we have a dialogue around that? And then what's the action plan, right? If we have low breaks, if we have, a poor finish on a surface, what is the corrective action plan for deficiency reports? What do we do, right? Who gets together? How's the discussion had? Who's all the stakeholders who need to be at the table to have this discussion? And then how do we resolve the disputes at the end of the process, right? So to me, these are just the things that I think of when I think of the agenda and what it should look like. It's a lot of stuff, but on large scale pours or on large scale projects with lots of pours, this is all stuff that's critically important to have dialogue about. So I really want to get into now the CRMCA. We're very lucky in Colorado that CRMCA has this pre-con checklist. And I can tell you that if not, I hope that all producers who belong to the CRMCA are putting this in their submittals, right? This really should just be plugged into every submittal you get so the engineer of record gets a chance to see this and look at it and to make sure that they're on board. But the concrete contractor and the GC, everyone should get this and take a look at it. They've done a really great job of distilling this down into 4 very simple pages that really, if you go through this, you're going to minimize a lot of potential issues from a testing and compliance standpoint on the ready mix side of things, right? Obviously, the first page is very simple, just names the stakeholders, right? And anything that's going on with any of the mixes that are in here. And then this is really important. If you don't do this on your job, I strongly encourage it, is do you ask, right? Are you, the testing agency, are you giving me a technician that's certified, right? This is important. It doesn't mean someone can get the test right, but it doesn't guarantee that they know how to do the test right? So one doesn't behoove the other. But if I know the person's certified, then I at least have understanding that that person should have the requisite skills to perform the test that they're required to do, right? That's the same thing for all of us. You wouldn't have someone placing concrete who didn't have knowledge of how to place it. So we need to make sure that the person administering the tests, right, understands what they're supposed to do. And unfortunately, in our industry, the concrete technician is often the lowest guy on the totem pole at the testing agency. you know? And so they're usually their newest people. It's usually a starter position. And it's kind of a crazy anomaly that we have inside of our industry, that this person who's testing probably one of the most expensive products on the entire job is, you know, one of the newest people typically in the industry and working at the agency. So asking this question is really important. And then, you know, do we have access to all the things that we need to, right? Is the site, does the contractor going to have the ability for the testing agency to come back and pick up their cylinders? We see this far too often, right? Those cylinders, and we'll talk about this, have to be picked up by in the first 48 hours. So when you have a pour on a Friday morning or Friday afternoon, they can't be picked up till Saturday. But is the job site closed? Can they come and even get those cylinders? Or do they have to wait till Monday? If you have to wait till Monday, you've already made those cylinders invalid, right? Because now they're not being picked up in the 48-hour window that they're required to be picked up in. And so having this discussion is really important. Can we get onto site on a Saturday, on a Friday pour to pick up cylinders and that? Do we have electrical power, you know? And is that power constant? Are we assured that the generator doesn't get turned off when everyone goes home on Friday night, you know, or each evening and that, so that the cure boxes and the things of that nature, you know, stay with the proper appropriate power that are required for them, right? So, and then where are we testing, right? ASTM would tell you that the point of discharge is where is required for the testing. Now, some people will try to take that as point of placement. Point of discharge is where it comes out the back of the truck in association with ASTM C94, but it doesn't mean that we can't do point of placement, but there has to be a dialogue around that. You know, we can't go out of specification to hope that at the point of placement, it's in specification, right? And so there has to be some dialogue around correlation testing and, you know, what acceptance and rejection has to happen at the point of discharge, right? But we all want a good product at the end of the hose at point of placement, right? But there needs to be a good dialogue around that as to how that happens, right? And what we're all going to do to try to make that happen and be successful. But I will tell you from years of experience, the angle of the boom, the pump operator has all sorts of effect on how that mix and the air in the mix is affected in the pumping. So, and it's not a simple science as some people would like to make it sound. It's not just, hey, if you flat stick out the boom, it doesn't have any issues, or if it's an A-frame, or if it's I've heard all sorts of things over the years. The truth of the matter is there's a lot of factors here that play into how that mix is affected inside the boom. So, and then going on to the next page, right? Who's responsible for adding water, right? Is there clarity of that, right? Is it the pump operator who's allowed to stop and call for adding water, or is it the place and finish crew, or is it the contractor on the job, or is it only the ready mix supplier who's allowed to add water because of the deeming of that from the, you know, from the person purchasing it? I don't know, but it's a really important dialogue to have, right? There's lots of other things on here that clearly need to get discussed, but I'm going to point out some of the really critical things to me that this pre-construction checklist talks to, right? Are we getting a proper field test as a part of this is really important, right? So remember, at the end of the day, you're looking for a third party, impartial person to test the concrete, right? So that's what has to happen, right? And we want to make sure that it happens right. So what does a good test look like, right? Well, from the basic standpoint, right, they got to fill that slump cone in 3 separate lifts, right? Making sure there's no voids. One of the things I see all the time is that when you go to that slump cone, right, comes at an angle like this. When you're rodding into that slump cone, the propensity is to rod out really easy, but it's not to rod backwards towards you. In that, because you have to move your hands in a forward motion to get that rodding on the backside of that cone to stop there from being a void on the backside, right? And so then you see when that happens, you get a shearing effect or a displaced center when the slump cone is pulled, right? And so making sure that the person understands that and they're rodding it properly. And then do you get a good 5 to 7 second lift, right? When he pulls the cone, right? Is there no break in the cone? Is it 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, right? A proper slump pull, right? To make sure that you have an accurate test coming out there. So, and then obviously you measure from the displaced center, right? So that sunken in little section right down in there, not off the edges. And if that whole thing shears, right? If this whole thing slides off, cuts or slides off, then it's a retest. You can't find the new displaced center. You have to scrap it and start over again and get a proper test here, right? And then, are we running our air test? I know you've never seen one of these in your lifetime look like this in the field. That's a beautiful looking air pot. They don't normally look like that at all. They're normally considerably beat up and concrete but understand this is a pretty precise piece of equipment, right? And it should be cared for properly, right? And so if you see someone that's got giant globs and stuff, the test may not be as good as you hope it is, right? But again, just understanding what that looks like. Are we making sure that, they've weighed their pot before they take their thing so they know how much they've got? Because you got to subtract the pot from the weight in that. And then, we're making sure that the lid seals properly. There's no air loss. That gauge shouldn't be moving right before you hit the release button on the side here. So in that, and then do we see a stable gauge reading at the end of it? And that, or is it still drifting? That all that stuff indicates that there's an improper seal around the bottom and that test needs to be rerun. And then all of that's to be said that really, look, at the end of the day, guys, whatever the air test says should coincide to the unit weights as well. These are just some general rule air unit weight densities, but this is also affected by whether you have any pozzolans in your mix, whether it's straight cement. So these numbers go up and down, but there's some general rules. These are kind of some of where you see airfall, right? As far as unit weight. And obviously the more air something has, right, the lighter it is in weight, right? So if someone comes and tells you that, hey, you're low on air, you got a 3% air, in your concrete right now, and you say, well, what's the unit weight? And they say, well, it's 33 pounds. They've lost their mind. Something's wrong. Something's wrong in the pot or in the test that needs to be done, and we need to look at that. But there needs to be a correlation between those two, and it becomes really important, And just understand, guys, air and training is the pink unicorn of the concrete industry. It's really hard to entrain air. There's lots of things that affect it. So understand that and have these dialogues in your pre-construction meeting about what happens on a day where we're struggling to get air right. Because it's not about if it's going to happen, it's about when it's going to happen. Because air is complicated. It's not simple. And there's all sorts of things that affect it. So, and then actually understanding too, are we having a dialogue about our field test and do we have a 90-minute rule, or are we really looking at the, the new ASTMs say that there is no 90-minute rule as long as you've had a discussion up front and that you're using hydration stabilizer and things to extend your time. And so if you have you had that discussion before you're in a situation where you're having to throw away trucks that may not have an issue? Understand concrete is in danger of flashing or going hard when temp changes happen. It's not what the initial temp is as much as the change in temp that happens. And so that's really an important part of dialogue, is to understand if I came out with 85-degree concrete and it's an hour later and it's 89 degrees, is that about to set? No, it's only moved 4 or 5 degrees in temp. But if I showed up at 70-degree concrete and I've got 85-degree concrete now I'm worried, right? Now I've moved 15 degrees. Now it's showing me that the concrete itself is firing, and now we have a potential issue on our hands. So having these kinds of dialogues up front so that everybody's on the same page is really important. And then knowing, what is your, max temp spec and where does that sit and time. So with that said, one of the great things that exists out here, and we're very blessed again in Colorado and CRMCA, that CTAC was created, right? What is CTAC? Well, it's the Concrete Testing and Adherence Collaboration. And this started a long time ago. I was very blessed to be a part of this when we initially had dialogues about the beginning development of this. But what is this really, right? It's designed to help make sure that we have good, fair testing of the ready mix products that are going down, right? On both sides of the spectrum. It's meant to get all tides rise, right? It's no different than when your person comes in and they install rebar, right? And they get the rebar installation done, what happens? Well, I'm sure that whoever's done with the installation, the concrete contractor comes in and checks the rebar and validates it, right? And then behind them comes the inspector. They come in and check the rebar, right? And if the general contractor's, on top of their game, they're going to check that rebar too, just to make sure everyone's got a double check. Well, it's the same kind of concept here, right? CTAC is here and developed so that there's an opportunity to make sure that the testing is going on, is being done correctly, and is being done according to the standards, so that we can rely on the results that come from it, right? Because if the testing is done inappropriately, then we don't know whether the test results are good or bad. And so it's better to see this up front and to know we potentially have an issue than again to get to the back end and be in triage, right? And here we are, everyone's scrambling, trying to figure out why the test failed and why is nothing going the way we wanted it to. So what does CTAC do, right? Well, first, let me help you to understand that CTAC isn't just, as you see here, isn't just in Colorado, but it has now got 11 partners across the US, right? And so there are all sorts of people who have picked this up and said, hey, this is really important. Lots of other states have come alongside and said, hey, this is really important and we need to get this right because it's been, a giant error place in our industry. It's been a giant hole that needed to be fixed. And what it is there's an application that allows anybody who's on site, the contractor, anyone who's, let me clarify, anyone who's an observer who understands how the test is run properly, can then observe and put down in their observations of the test. Is it being run according to the protocols, right? And then that's allowed to evaluate that afterwards. Well, what does that look like? Well, it looks like this. You start to get these observation points, right? And so if you're gonna do this, if you're gonna put CTAC in your job site and say that, hey, this is important, and that, then you have the ability to come in and get monthly or weekly reports like this that can tell you, hey, how are we doing on these pours? Are we getting testers that are certified? Are we making sure that all the samples are done correctly, right? Are the physical properties, coming in compliance as they should, right? And then are we storing specimens? Are we storing specimens appropriately? And that, yes, no, are we missing certain pieces? You can see here, you can see when everything goes well, and then, hey, maybe they're missing a piece, maybe they're, so are we meeting initial curing? Are we missing just the temperature control? If we're missing the temperature control, we may not know whether we're in compliance or not, right? Because that's equally as important to this. With that said, I'm going to tell you now, CRMCA tells you that there may be up to a 20% reduction in compressive strength if curing is not done appropriately. I'm going to tell you now, I'm going to show you some data from testing that was done by a whole lot of people in the CRMCA, both technicians, testing companies, ready mix suppliers, and contractors in a test fest. And I believe those numbers by the NRMCA are pretty conservative in reality. So, but with that said, what is the requirement? The requirements are that after molding, immediately after molding, they have to be stored in a 60 to 80 degree environment, preventing moisture loss. Both of those things are critically important here, right? Cylinders have to be held at 68 degrees, and moisture loss is just as important to that. And often it's not thought of as so, and we'll talk about that some more as we go. And then understand, when you have 6,000 PSI and greater, that window gets even smaller. So now from 60 to 80, you're down to 68 to 78. So you've really got to control the temp on high strength, mixes to make sure that they're done right. And then how are they transported afterwards, right? That's also as important, right? You can't transport them till at least 8 hours after final set. Any earlier than that, and you fear creating fractures in the cylinders that will give you false negatives, or false positives or false negatives on the test, right? So, and you got to make sure, I've seen this a lot of times. I walked onto a job site one time and the guy was grabbing all of his cylinders and they were throwing them across a 8-foot void where the foundation was, because he didn't want to have to carry them to the other side. So he was just grabbing the cylinders and throwing them like 9 foot across this chasm to the other side. I don't think that's probably what they were designed to do. And there's a good chance that those cylinders get compromised in that function, right? So it's just important that we have these dialogues up front about what the expectation is and how the cylinders get treated along the way. So what does proper field testing look like, right? Well, here's exactly what we talked about, right? You need that controlled, temperature controlled environment for 68 degrees. You need to prevent moisture loss, and you need that high-low thermometer. Otherwise, you can't prove whether or not this happened or not, right? So we don't know whether the cylinders are compromised or not. So let's take a look here. What do you think here? Is this a proper cure box? Well, let's point out a couple things. One, there's at least a high-low thermometer down in here, so that's a good piece of news, right? At least we can measure whether it is in here. For those of you who can't necessarily see this, there's a couple of incandescent light bulbs in here that are meant to provide heat to the cylinders. I'm not so sure that works really well. Although it's providing heat, these cylinders here are probably getting a lot more heat than the ones way over here coming off of that. And so you may see some differences in your cylinders in here. This isn't really an insulated box, obviously. You know, it's got some cardboard and some plywood on the sides meant to kind of, I guess, hold in the heat. It's better than nothing, but I wouldn't say this is a great cure box, right? Well, here's what we see a lot, right? Here's the cooler. Hey, the cooler can work. I've seen it work. You know, in the summer, this cooler really needs to be filled with water, right? And not just partially filled, but all the way filled. Why is that important? Well, because if you don't fill it all the way, you fear of cold jointing. And I'll show you a little more about that in a second. In the wintertime, closing this up might be a problem too without any water in it. Because now it's 60 to 80 degrees, guys. You close that thing, and what's a cooler meant to do? It's meant to keep things cold and keep things hot, right? So that cylinder is creating heat. If this thing's packed full of cylinders, that thing's probably going to get to 110, 115 degrees now. It's not going to regulate that temperature, right? So we've got to think about that. That's why a high-low thermometer is really important here. What do you think about these little soldiers? Think they got a good chance of being at 60 to 80 degrees? I doubt it, right? I always talk about cylinders and say, you got to think of them like little kids, right? The slab is like the parent. It's got all this heat and mass. Would you put your kids out at night, you know, to go through a cold evening, or would you rather put yourself out in that cold evening to survive till morning, right? Probably you're going to do yourself, right? But we do this all the time. We put these little cylinders out in the cold and expect them to somehow make it to the other side, and they don't often do so. And then the wonderful Homer bucket. We've seen this lots of times. Look, this isn't all bad. I'm not going to say it's fantastic or horrible. It's definitely not fantastic, but if this bucket's got water in it, then okay, it's not bad. But the problem is this bucket may have water in it, and then these top cylinders sit outside. Well, guess what happens when this happens? Even if this bucket was to be full of water all the way to the top, these cylinders that are sticking out, these are going to cold joint, right? What do I mean by cold joint? It means that the bottom is going to set at a different rate than the top, right? So now the cylinder physically creates a fissure in itself. So when you go to do a compressive strength test on this thing, and I go to squeeze down on that thing, there's a natural break already in that cylinder that's now going to crush, and it's going to give me a false test result. You've often seen this in this kind of situation. If you go back and look at some of your test results and you see, you know, maybe you have a 4,500 PSI mix and you have, you know, 5,000 and 5,000, and you've got this one cylinder that's 3,000. And you're like, well, what the heck happened? Well, that may be that lonely little cylinder that was sitting outside the bucket, right? And now it's pulled your whole test result down and you failed, when the truth is that you didn't really fail in the first place, right? And having a discussion about cylinder care is always important. What could possibly be wrong with this picture? Any guesses? We won't wait, but if you didn't notice, they're kind of masked in here. These little cylinders look like they may not have looked like they did when they first came through, right? Well, what might have happened here? Well, look at our giant tracks. Here's our culprit right here. They ran right over the cylinders and just picked them up, set them back down and said, ah, they're good. This is not a good situation, right? Obviously, these cylinders are not cured properly. They've now been run over. They're probably suspect. I would tell you, knowing these cylinders and this whole story, this was an incident report. We shared it with the testing, with the contractor, and sure enough, the testing lab came back and these cylinders were low. Go figure, right? But something else you may not have noticed, look back here. We got a second set of cylinders pushed off into the back, right? And these guys are in the Homer bucket with no water, no anything on a hot summer day. They weren't necessarily any better off, right? Hanging out back there. So getting proper curing, guys, is really, really important. And here's the data that I was talking about that should really help drive this home, right? CRMCA ran a test fest quite a while ago. We need to redo a new set of this with new data and the more current mixes, but this data is still functionally the same for all of what concrete does, right? And here's what we did. This was a cold weather day, so the day of the casting got up to 57 degrees, the night got to 28 degrees, okay? And then here's what you had. You had some cylinders that were put in an insulated cooler with vermiculite. Vermiculite's a great sawdust-looking substance. It really differs heat, does a really good job. Vermiculite in a cooler tends to work really, really well for keeping everything in there in the system at a more controlled temperature. And then you had another set of cylinders that were just left outside in the ambient air. Now look, it wasn't a real freezing cold night. 28 degrees, we're just below freezing on that, right? But look what happens, you guys, when you do this. The outside ambient air temp at 7 days were 1,750 versus 3,600 for the ones that were properly cured. At 28 days, look what happens. You're at 5,230 as opposed to 3,480. That is massive. That's a massive loss in temp. You had a 46% loss in overall strength because they weren't cured properly. And this wasn't, understand, this isn't just, this is the average. So you had a ready mix truck show up on this test fest, right? And then you had about 15 to 20 testing agencies and ready mix suppliers all pull samples themselves off the exact same truck. And then they all cured cylinders in these two ways. And this was the average of those cylinders. So this isn't like, hey, we just took this and had one bad break. This is a common thread across all these test results that came through, okay? So now let's go to hot weather, right? It's better in hot weather, right? So now here's what we did. You had one set that stayed in the rules here. So you had an insulated cooler, just like we had shown before, but this one's filled with water, right? And you're at 71 degrees up to 80. So you're right in line with ASTM results, right? Your 7-day results are 3,600. Your 28-day results is 5,125. Then in the second one, you put an insulated cooler out here, right? Without any water in it. This is what we were talking about earlier, right? Hey, is that cooler okay? Well, no, because now look what happened. You went from 76 degrees to 105 degrees. Why? Because that cooler is meant to keep things cold and keep things hot. So when you put a bunch of cylinders in it that heat up, now it heats up that way past your 60 to 80 degree requirement, right? So, so without the water, we lost 12% of our strength, right? Now look, as I would expect, our 7-day strength is great, right? Why? Because it got to 105 degrees. So you really pushed that concrete into initial strength. You gave it a good kick early on. But the problem comes is that it got hot so fast, you shelved the strength. So at your 28-day, you lost 12% of your overall strength because you've got so much heat early on. Now, for those of us who don't think that moisture loss is of significance, it really does matter. Look, on the one set out in ambient air exposed to the sun, we actually were better. We were at 67, so we're inside of regular here, and we're at 93 instead of 105. So we're actually closer to where we should be, right? So you would think this should be slightly better than this one. But since you lost that moisture because they sat out to open air, they weren't, at least in the cooler, you controlled the moisture, right? That cooler was closed and the moisture stayed inside those cylinders. But because these are out in the open air and we live in a high country desert in Colorado, look what happens, right? We get 67, we only get 2715 as our initial 7-day, and we get 3610, a 30% loss in compressive strength because we just added the factor that we lost the moisture. So sometimes when people say, hey, we're sticking them in our trailer, construction trailer, and that's good, it's not good enough. If you're in a construction trailer and the AC's running and the heater's running, what are you doing? You're drying that air system out constantly, right? So you're sucking moisture away from those cylinders. Those cylinders still need to be stored where they can retain their moisture, okay? Really important pieces of this. So just real quick, just some specifications. Just wanted you to know everything we're sharing with you and both the stuff that's in the pre-con checklist that I went through. All of it lists the ACI or the ASTM specifications that these things are pulling from. So the beauty of that sheet isn't just the fact that it helps you to know what to do and to try to get around the pitfalls, but what's even better about it is the fact that it lists the literal specifications that you're quoting for, right? And so that's really important because now you know what leg you're standing on and where that came from. So, and then just looking at general specification, when we look at ACI 132, responsibility for care of test specimens, right? It says very clearly, here's what the EOR, the engineer of records responsibilities are. Here's what the contractor's responsibilities are, and here's what the third-party testing agency is responsible for. It's very clearly drawn out. And I want to make sure you have a chance to see this. Again, this presentation will be up. I don't want to belabor you by reading to you. I know you can read. You can certainly come back and check this out at a later time. But this is a really important slide. That's why I wanted it to be here. And JT as well, is we really felt like it was important for you to kind of have this listed out for what the responsibilities of each of the parties are. And again, take that into your pre-construction meeting to make sure each person's fulfilling their responsibilities, right? As to what they're required to do for test cylinders. So there's also the CRMCA has a pre-construction checklist out there as well. It is way larger. The CRMCA's pre-construction checklist distills it down to 4 pages, right? Very simple, but it's really focused around cylinders and testing of the ready mix product itself, right? And that's what it's focused on, is making sure that you get a good test on the other side. The CRMCA pre-con checklist was created in conjunction with the ASCC, the American Society of Concrete Contractors, and it's 25 pages long. It's a great resource for a pre-construction meeting, for the whole meeting, right? And it really goes far more into all the details. This document, if you've not run a good pre-construction checklist and you don't know, and you were looking at some of those subjects that I had on the beginning, all of that list of green subjects on that tile board are inside the NRMCA's pre-construction checklist, right? And so it's really there, and you can really go through that if you've never had a chance to do one of those before, and I strongly encourage you to use these. But again, it gets much more into detail around construction processes and sequencing and all your materials and your schedules and traffic potential issues and cancellations. And it's a really, really great resource. And it's much more safety focused in its nature. So it really talks about each of these different elements and what potential safety issues could be around those things as well. So I strongly, strongly encourage you to do that and to take a look at that if you haven't ever seen that before. So with that, I would like to open it up to questions. If you've got any, I'm happy to answer anything you might have. And
do we have some questions out there? Just feel free to turn on your microphone and ask away. I don't see anything in the chat. Well,
Good.
that means it's pretty thorough, Dana. I'll tell you what, a couple things that just stood out to me and to recap here is all of those boxes on your first couple slides, phenomenal. All those things come into play to make it successful. And many times we don't think about all those steps, but they're obviously very critical. So last chance for questions. I see one chat. Great presentation, Dana. That is not a question, that's a comment. Thank you for that. Okay, so one quick thing. Okay,
Yeah,
Dana, can you
JT,
read that? What does
JT,
full of water mean? Do the cylinders need to be fully covered?
say that again, Todd?
What does full of water mean? Do the cylinders need to be fully covered?
Yes, yes, absolutely. The cylinders need to be completely submerged in the water if you're going to water bathe them. Yes, absolutely. Great question. Yep. Sorry if that
Okay,
wasn't super clear.
I said thank you. Okay.
Todd, JT did have a couple of things that people had put in
Okay.
prior to the thing, so I did want to cover. One of the questions that they had was, how do you discuss or encourage the implementation of innovative materials in the pre-construction process? It's a good question. It's complicated at the pre-construction meeting because usually you're so far along in the process that it's often tough to backtrack and have a discussion of changing process, right? Usually a lot of things are locked in. It's a difficult situation we have right now in the sense that usually that needs to happen early on in the bidding phases is really where you need to have that kind of dialogue with whoever the contractor is going to be, right? What materials might you use? What else would you need to do? But trying to do that late in the game at a pre-construction meeting, I've not found usually to be very successful. People are pretty locked in. You're usually pretty close to things getting started, and making changes of that nature usually don't work well. So.
Dana, a question. Is there a way to, I assume this is in regards to the water elevation. Is there a way to see when you strip the samples if there is a cold joint?
It potentially, not always, potentially, but that fracture is typically pretty hairline across the cylinder. You'd have to do a pretty tight investigation of the cylinder. And by time you get it to the lab, the problem is that it's been intermixed with all the other cylinders, that someone's picking up. Usually understand when people are picking up cylinders, they stop at 1, 2, or 3 different jobs, picking up cylinders and taking them back to the lab. So by then they've all been kind of jumbled and mixed up. And a cylinder, for those of you who haven't seen one before, is really a pretty polished surface when it sits inside that mold and it's properly consolidated, right? It's really kind of tough you'd have to investigate that thing pretty closely to see that ahead of time. And I would just tell you in general, nobody's going to spend the kind of time in the breaking process to really investigate every single cylinder, especially when a testing lab could be breaking 250 cylinders or more, right, a day. So at that point in time, just with the time it takes to break each cylinder, you're not gonna do that, right? So, but this is why it's important to see these things and to report them on the day of. And that it leads me to one last thing I do want to say about that. I've seen this far, far too often. If you see something that's not right with a set of samples, it's important to report it, but it's also important to talk to the people and fix it. I see far too often we go ahead and make a report, but nobody had a dialogue with anybody about fixing what was wrong. I liken it to watching someone who's about to jump off the edge of a cliff and going, yeah, look at that guy over there. He's about to fall off the cliff. Yeah, we'll document that. as opposed to going and stopping the human who's about to do that, right? You can always document it later, but let's fix the problems, right? And that's part of what CTAC is really trying to do, is it's trying to invigorate people to be watching these things so that we catch them before we get, you know, to the catastrophic end of a low break, right? That's an unnecessary reality.
Thank you very much for that, Dana. One thing I want to talk about for tomorrow. It's not one of our webinars, but it's one with CDOT, and that involves the EPD process and where they're heading. I think they're going to take their first cut at rolling out global warming potential, the GWP limits. So that is a very, very important meeting that we will certainly be on. And but yet all that information went out to all memberships. So please participate in that, and if you haven't received that, reach out to JT or Megan. We'll make sure that that came. Many of you should have received that directly from CDOT. So with that, I want to again thank our sponsors, and I thank our speaker, Mr. Dana Roktovich. And Dana, trust me, I'm hoping this is not the last seminar you do for us. Thank you very much.
Absolutely.
Thanks, everyone.
Appreciate it.
Dana.
Thanks, Dana. Thanks, everyone.
Thank you.
Take care all.